it's like for maths, it's like you create some sort of problem that you want to solve. For example, no, not a major complex mathematics, more of a real world problem you want to solve. Like, this is getting people ready for that. So if you chuck something in the air, what function does it create? What's the highest point of it? What distance does it travel? What's its speed, perhaps you could look into? What's the area under the curve? And all sorts of things like that. And then discuss its limitations, reflect on it. And that's an IA. It's a simple IA, but it's an IA. So optimization, here's a question I thought of. If I have 40 meters of fence and a wall that's already set, so here's a wall, what's the biggest area of the field I can make? So I put some fencing out here. What's the biggest area I can make? Let's stick with rectangles for now, or squares. Let's not make it too complicated with circles.
Wait, what's that little square you do? That's the wall.
That's the wall, yeah. So we can have what's the biggest size field we can make?
You only got 40 meters of fence for the wall?
Yeah, you got 40 meters of fence, you can use the wall.
100 meters? 20, 10. So you have 3 sides.
Yeah, you're working with, the fence is split over 3 sides, yeah.
10, 20.
You sure?
No, because that's not going to connect back to the... No, you got to do 40.
So here.
10, 20, 10.
Okay, let's use a different size. 70.
Oh, the wall's infinite length.
Well, the wall, we can just use the wall as much as we want to use it. So you can have a really thin, long field, or a square field, whatever you want to use.
Wait, what's the area actually?
I'll just...
But if you use the whole fence, wouldn't it be the same area every time?
Would it? Is a field that's really long and thin got the same area as one that's like this and use the same amount? It's the same?
It would. Yeah.
You sure?
No, it's
Oh, let's use.
using the same amount.
All right, let's use 40. Let's just say it's 2. We use 2 here.
Yeah.
What's this length?
36.
36 left over. So the area of this is 36 times 2, yeah? 72. All right, let's say we use 10 and 20, yeah. What's the area of this? 200. So we can create a load of different fences or areas. So many areas. Well, let's create one in general. Let's just call this X. If this X and this is X, what's this side? No, we do it. 40 minus 2x, thank you. 40 minus 2x. What's the area of this field?
40x minus 2x.
Yeah. So that's 40x minus 2x squared. Okay.
Can you put that into like
So this is the area. Now, normally when we look at the graph of a quadratic, we go y is equal to x squared plus 5x plus 6, and we draw a quadratic, and this is the y-axis, and this is the x-axis. This is a quadratic, we agree? But all the answers will give what now? Area. So the y-axis is the area, the field of the created field. So when we sketch this thing, we'll get something like this. This is now area, and this is the x length. Where do you think the best, the maximum? Yeah. You're looking, so if we found the maximum of this, and how do we go about finding the maximum of a curve? Vertex or axis of symmetry, yeah? So if we just go straight to the axis of symmetry, what is the axis, not the axis of symmetry? The axis of symmetry will give us the x value. So if negative 2x squared plus 40x, we don't have a c, but that's okay. Yes, I put in right order now. 40x, not 4. 40x. So if I use the vertex form, the vertex minus b over 2a, the axis of symmetry. The x will be minus b, which is minus 40, over 2 times negative 2. So that's, what's this? 10. So you were right when you said 10 and 20. Who said 10 and 20? Joshua. Yes, 10 and 20.